In this video, we're going to look at enthalpy calculations. Using a thermal equation, a balanced equation that tells us how much energy is either absorbed in the process or given off in the process, we should be able to calculate how much energy is required to either consume a reactant or to produce a product. Let's look at an average problem. Calculate the energy required to produce 100.0 grams of glucose given the following thermal equation. 6 H2O liquid plus 6 CO2 gaseous will produce C6H12O6 solid plus 6 O2 gas. Gives us delta H equals positive 2,803 kilojoules per mole. So this equation is asking us to figure out how much energy is required to produce 100 grams of glucose, C6H12O6. That means, if we look at the thermal equation, for every mole of glucose produced, 2,803 kilojoules is required. Now, for the thermal equation, we need to watch our stoichiometric coefficients. So notice that we have a 6 in front of the water, 6 in front of the CO2, and only a 1 in front of C6H12O6, the glucose. So therefore, for every mole of glucose we get is required 2,803 kilojoules. Since we know that it is kilojoules per mole, to get the energy required, all we need to do is multiply 2,803 kilojoules per mole by the number of moles that we're going to be producing. Therefore, we'll take 100.0 grams of glucose multiplied by 1 mole of glucose per 180.2 grams of glucose. Grams of glucose cancel, giving us 0.5549 moles. So we'll take moles of glucose multiplied by the delta H reaction that we got from the thermal equation, and that will give us the energy required. So 0.5549 moles times positive 2,803 kilojoules per mole. Moles cancel. We do the mathematics and we get 1,555 kilojoules. The amount of energy required to produce 100 grams of glucose, 1,555 kilojoules.